solving. This is really just a lot of visuals and a lot of graphing and, you know, kind of just looking at it and still exploring. Tomorrow we will really start getting into like the heart of this chapter, but these first 2 days we're kind of like just getting your feet wet with just understanding what the inverses are. Okay, so let's take a look. Sketch the inverse of the function represented by the graphs below. We did this yesterday, but I gave you points yesterday. Now we're going to make our own points. Okay, so whenever there's like, I kind of put dots on them for you. If there's like an intersection, I would recommend using those. So I'm going to make a table for myself. So this graph is blue. So f of x, let's figure out some points. From left to right, I got -2 up 1, 2, 3, 4. So I'm just going to write that out. -2, 4. And then I have -1 up 2. So -1 up 2. And then I have 0, 0. And for a line, I really only need 3 points. You could do as many as you want, but for a line, you really only need 2 points technically. For other graphs, you will need more. But let's talk about what the inverse would look like because that's the goal. So in purple, we want to figure out what the inverse is. Someone asked me last period what that -1 meant, and that was a very good question. It just means that that's the inverse of the original. So that -1 represents inverse of f of x. Okay, so this is going to switch. What is this going to become for the inverse? Yeah, 4, -2. They just switch on us. Did you have a question?
How did you get -2, 4, -1, 2?
I got them from these points. So -2 up 4 is right here.
Oh, okay.
We're just taking them from the original. Yep. Okay, and then we have 2, -1, and then we have 0, 0 just becomes 0, 0. Hi. Thank you. Okay, thanks. All right. Now let's graph it. So let's go ahead and put that on the graph. We have 4, 1, 2, 3, 4, down 1, 2 in purple, and then I have 0, 0, and I have 2, down 1. And again, you can keep going. You can get more points if you want, but when you have at least 2 dots, you can make a line. And it's easy to go left to right. You can use your lanyard, and we're done. They just wanted you to graph that inverse. And I'm just going to label it. Here's our inverse graph. Just like I labeled, this is my original. Now, I'm going to explain something again that I explained yesterday just to make sure that you understand what's going on. This line right here, I'm going to highlight it, and I'm just going to write y equals x. I told you yesterday that all inverse functions are symmetric over the line y equals x. So what does that mean? If I took this purple arrow and I flipped it over, it would now become the blue arrow. If I took this purple arrow and I flipped it over the yellow line, it would become this one. So when you fold it, it would become one line. It's pretty cool to see. Okay, so that's what it means to be an inverse, is to be symmetric over that line y equals x. So just kind of going over that again. Let's do it again. For these ones, I'm going to recommend that you get more than 3. You get 5 like I put on there for you because the shape of it can be a little funky towards the end. So I'm going to go left to right. I'm going to use my blue again. F of x is my original. So I'm going to do this left one. So 1, 2, 3, up 1, 2, 3, 4. So I have -3, 4. And then I have 1, 2, up 1. So -2, 1, 0, 0. This guy I have +2, down 1. And I have +3, down 1, 2, 3, 4, down 4. Do you have questions on where I got any of those points? I just literally took them from the graph. Now, yesterday, the only difference is that I gave you those points. That's it. Okay? Now, for the inverse in purple here, I'm going to figure out what those points are. I'm not going to do it. I'm going to have, yep. Why don't you guys take a minute and just figure out what 5 points you're going to have to put on the inverse. Which, again, it doesn't matter what order you put these. Someone was asking me, like, oh, I put this one first. I don't care as long as you have the correct points. I'm good. Okay, so go ahead and flip them and see if you got them right. A lot of people like this chapter because it's more of graphing and people like visuals sometimes. We will get into radicals later on in this chapter too, though. Check and see if you got that right. Zoom in for you. And then if you got that right, awesome. Let's just go ahead and sketch it for ourselves. So I'm going to go ahead and graph it. I have to the right 1, 2, 3, 4, and I have down 1, 2, 3. I have to the right 1, down 1, 2. I have 0, 0. I have -1, up 1, 2. And I have -4, 1, 2, 3, 4, up 1, 2, 3. Now, some people ask me how to draw this, and I get it because sometimes it looks weird and confusing to draw it. Go left to right. Like, you ever play like the connecting the dots game, like when you were little? Go left to right. So here's my leftmost point. So I'm just gonna go left to right and watch. I'm just gonna connect the dots, and boom. And you can kind of just like extend that there. And I'm gonna write out that this is the inverse, so that you know when you go back. It should look like the literal exact opposite of the other graph. The other graph was pointing up, and now they're pointing to the left and right. They were pointing up and down, and now they're pointing left and right. They're the opposite, because that's what inverses are. They're opposites of each other, okay? And again, if you were to take this purple arrow and flip it over this dotted line, it would now become the blue arrow here. If we took this arrow and flipped it over, it would now become the blue arrow here. That's what that is, the symmetric, okay? Questions? That's kind of review from yesterday. We did do that yesterday too. When you're done, flip the pages so I know I can move on. So that was all just sketching. Sketch a graph of the inverse. Now we're going to talk about, if it's a function or not. Remember, to qualify to be a function, you can't have more than one output value. If I give you 2, you can't output -2 and 3. Like if I say 2x, like you can't get 2 times -5 can't be -10 and 10. It can only be -10. Okay, so that's really what it means to be a function, and we're going to talk about that with inverses. Yes, well, in maybe freshman year or earlier, you guys learned about the vertical line test. So hopefully that kind of rings a bell. If it passes the vertical line test, your graph, your original graph, is a function. So let's take a look at this. If I draw a bunch of vertical lines, you'll see that it only crosses one time. So if I was like, don't do this, but if I did all of that, it only crosses one time. That proves to you that it is a function. That's called the vertical line test. So if I do this, it only crosses once.
Oh, I thought you were talking about that.
It's okay. All right, so this would be a function, and that's because of the vertical line test. And when we talked about inverses, remember everything is the opposite. So if it's vertical for normal, your inverse will be horizontal. And that's why we're doing horizontal line tests now for inverses. Okay, so we're going to use the horizontal line test to figure out if the inverse is a function, not the original. The inverse is a function. So I'm going to have you guys draw this in. And we're not going to draw in the inverse function. I don't think that we need to. But I'm going to draw this in. If I draw a line right here, and I'm going to put in here HLT for a horizontal line test so that when you go back in your notes, you know what I'm talking about.
Should we try that?
Yeah, I want you to draw this one. It crosses 1, 2 times. So would the inverse be a function? No. No. Okay? It's not, because it does not pass the horizontal line test. So again, this graph right here, f of x, is a function, but when you graph the inverse, which will rotate, it's not. Okay? And that we can prove that just by looking at it and using the horizontal line test. So because it crossed twice, that's why. It can only cross one time. And Aladdin down here is telling you that information. It says that you can figure out if the inverse is a function based off this. So I'm going to put a 1 here, and that's what makes it a function. And because this guy crosses 2 times, it's not a function. Just kind of like highlighting for you that crossing 1 time is great. Crossing twice or more is not okay. It would be not a function. What'd you say? Oh. Okay, so let's practice it, right? So let's take a look at this first one. If I draw in a line, I'm just going to draw it in, and I'm going to write HLT just so that you know that that's what we're doing. And obviously you don't have to write that every single time. But look, it crosses 1, 2, 3 times. So is the inverse a function? No. So I'm going to write this out. The inverse is not a big not a function. A lot of people were getting confused last hour saying that they were confused about, are we talking about this graph or are we talking about the inverse graph? We're talking about the inverse graph. So all of the work that we did on the first page where we drew our own graph, that's what you're talking about. The inverse would not be a graph. Let's do this next one. If I draw a horizontal line test here, HLT, it only crosses one time. So the inverse would be a function. The inverse is, in caps, a function. Okay, because it crosses one time. And again, you can keep doing it. Like if I'm like this and this and this, doesn't matter where you put the line, it only crosses one time every time you draw a line. Okay, this next one, I'm going to draw another line. Is the inverse a function or is it not a function? It's not a function because it crosses one and two times. So I'm just going to put not. I'm not going to write it out again. It's not a function. Do you have questions on the horizontal line test? It's pretty straightforward visual here. We got one more little piece.
Excuse me.
What'd you say?
So if it crosses one time, then it is. If it crosses more than once, it's not.
You're right. Okay, flip when you're ready so I know I can move on. We only have a little bit left. Okay. Okay, so take a look at this. It says graph the inverse function, which we did on the first page, and determine if the inverse is a function. So those are two things we just talked about just now. So let's take care of those first. The first thing I'm going to check is the inverse a function? If I do the horizontal line test, would the inverse be a function? No. So this is not a function, okay? Because when I do that horizontal line test, it becomes, the inverse would not be a function, crosses twice, okay? Then I would recommend doing your domain first of the guy, because when you draw in the other one, it might confuse you just because you're drawing something else in. So left to right, is this graph going to be restricted at all, or is it going to go on forever? It's going to go on forever. It goes on forever to the left, and it goes on forever to the right. So this is going to be all real numbers here. Now I'm just going to do something. I didn't ask this question, but I want to prove it to you when we draw in your inverse function. Okay, the range. I just want to ask you this question, like I said, because I'm going to prove to you something that I taught you today and yesterday. What is the range of this graph? What's the y value we start at? Yeah, -1 to infinity. And the reason why I'm doing that only is because I want to show you what happens to the inverse function here. Now, there are two ways you can do this, and I'm going to show you a quicker way if you're someone that doesn't need the visuals. I'm going to tell you right now, if you're someone that likes to write things out, you will have to do like this. You'll have to write out, the f of x and then switch them. Or if you can just do it in your head, do it in your head. So I'm going to show you how you would do that kind of in your head. For some of you that, I think half of you will be able to do that right now. So here, I have -1, 0. So what's my inverse going to be? 0, -1. So I have 0, oh sorry guys, it's 0, -1 already. I messed that up. And when you flip it, it becomes -1, 0. So my inverse is here in purple. That's my inverse one. Okay, and then I'm going to do these two right here, because look, they cross. So I have 1, 0. So what's going to happen? What am I going to have now? 0, 1. So in purple, I'm going to have 0, 1. Again, I'm showing you mentally. You don't have to write all of that workout we did in the first page if you can just do it. This guy, I have -1, 0. So then I'm going to have what? If I have -1, 0, what's going to happen? 0, -1. So this guy in purple. Now you can't really tell the shape of the graph yet, so I'm going to pick another point. The best way to pick a point is if it crosses. So right here it crosses, right? So that's -2 up 3. So now what am I going to have? 3, -2. Thank you. 3 down 2. Last one. I'm going to pick another one. 2, 3 becomes 3, 2. So 3 up 2. And now look, there's my graph. And you can see that it literally like just rotates and goes to the side. And that's what happens every single time. It like does like a 180-degree flip. Okay? Let's talk about this. The domain from left to right of the purple graph here. Where do I start on the domain? This is my initial point. -1. So -1 to infinity. And now take a look. And this is what I wanted to prove to you. Yesterday I told you that inverse functions, the domain, the range, switch. And look what happened. The range became the domain. You see that? The range became the domain. That's why I just want to prove that to you by showing you it. Okay? That one is probably going to be your hardest one of all of them. The rest of them I think are pretty easy. Because this one, it goes up forever and down forever, so that's going to be all real numbers. Okay, let's do it again. Is the inverse going to be a function here? It is or is not? It is. Okay, here's why. If I do that, it only crossed one time. If I do that, it only crossed one time. Okay? I know it gets like flat towards that middle, but it really never is going to be more than one. So that's great. What is the domain of this graph? Because this is f of x. Yeah, negative to positive. It goes forever up and forever down, forever left and forever right. Now let's just graph our other guy. Again, pick some points. I'm going to come and do like, I'll write it out here. I'll do, this guy looks okay. This guy looks like it's negative, and I'll write out -1.5 comma 3. So when I switch it, it becomes 3, -1.5. So 3, -1.5 here in purple. So that black dot became the purple dot now. I switched them. Okay? Then it looks like I have in black -1. Oh, that's supposed to be black. -1, 1. When I flip them, it becomes 1, -1. Here in purple. Question so far? Okay, again, you can write them all out like we did in the first page, and you'd be fine. Okay? And then I'm going to do, well, 0, 0 will just become 0, 0. When you flip 0, 0, it becomes 0, 0. Okay, then I'm going to pick a little further of a point, because sometimes it's hard to get that shape until you get a further one. So this guy looks good right here. I'm going to write it out for you. 1.5 comma -4. So that's going to become -4, 1.5. So in purple, -4, 1.5. And again, it's really weird because you got all these dots on paper. But go left to right now. Follow the purple dots. So left to right. I'm going to follow the purple dot, and it looks something like this. Here you go. That's a good meeting. Switch ya. All right. What is the domain of that purple graph? Does it go forever to the left and forever right? Yeah, it does. So all real numbers. You can see it's pointing left and pointing right. Okay. Lines, I feel like I'm not going to do another line one with you. We've done line ones a lot. So you did a line on day 1. And we did a line earlier today. So if you have a question in your homework that refers to one like this, go to a previous problem. Okay, I'm going to go to 7D because it is a little different. Is the inverse a function? When I draw a line, it only crosses once. So is it a function? Yes. What is the domain of this graph? Do you see how it stops here?
0 to positive.
There we go, 0 to positive infinity. You see how the x value starts at 0 and goes on forever. Okay. Now, here we go. Let's plot some points. 0, 0 is going to become 0, 0, right, when you flip them? Same with 1, 1. 1, 1 will become 1, 1. I mean, they're not, and there's no difference. But there is another point over here, 4, 2, that's going to become what? 2, 4. So 2 up, 1, 2, 3, 4. And left to right, boom. That one was easy compared to the other ones. That one you can see the shape is going to be pretty straightforward. Okay. What is the domain now of the purple graph? Where do I start? 0. Again, I'm going to go to infinity. Okay. So the biggest thing is just, we will do a lot more with domain and range tomorrow, but I want to get your feet wet. take your time. You have a half a period, which is a very long time to do 9 questions. The key is on the board. If you have a question on number 8, sorry. No, actually, no, there is no line 1 on there. Never mind. All right. Questions 1 and 2. I said it a couple times, maybe like 5 times today. And I said it yesterday too. I want to see if you remember. If you don't remember, go to day 1 where Abu is on the notes from Aladdin. He tells you those answers. Okay, so there's like a big Abu there. And I wanted to see if you could remember without looking at your notes. If you can, great. But if not, then what is true about their domains and their ranges, you should know. We've said it a million times. And then their symmetry, it's over the line y equals something, and I highlighted it in the front page, or that's right by Abu. Okay, that Abu character from Aladdin.
Monkey guy?
The little monkey guy, yeah. You can work together, you can work alone, whatever you need to do. Let's just like during those, you guys test. If you have questions, ask. The key is right here. Check your answers. They're based off your notes, so you would refer to them